Hey there, welcome to the intro video for our newest unit where we're going to be exploring three-dimensional measurements. Now in our previous unit we talked about 2D area, perimeter, and circumference. And so for example, if you had a rectangle, we talked about how to either find the area inside the shape or for example the distance around it with perimeter. We talked also about circles, and circumference would be the distance around it. So now we're going to kind of move away from the 2D stuff. This was, again, the previous unit was 2D, and now you should have already matched up the nets for the 3D figures and a 2D net. So the first one that I have here for y'all is the cylinder. The cylinder matches right here. We can see the two circles on the top and bottom, and then this part kind of curls around, almost like the label of a soup can, okay? So let's go ahead, and if you guys will take notes on this, let's label the first one a cylinder, and you can just write that next to it, okay? I'll erase this just so it's not too confusing, and we have our first 3D shape labeled. That's a cylinder. All right, now the next one is a cube, and its net is right there, okay? So we have the net of a cube. Go ahead and jot that down, that's what that shape is. Now this tent-looking thing is actually a triangular prism, and its net is the first one right there, where you've got this bottom part, and then you fold up kind of the two triangles on the side. So here we have a triangular prism. All right. The next one is a cone. A lot of us are familiar with the cone, and its net was this one. So let's go ahead and jot down the word cone if you haven't already for this one. Now the next one we see here, this is, I want you to try to imagine that that's the bottom. It's kind of a see-through shape, and that's the bottom right there. That's a triangular pyramid, y'all, and this one matches up right here. So we have that triangle bottom, and then these three sides fold up. And the last one here is a rectangular prism, and its net is the second one right there. So we had a triangular pyramid, okay, a pyramid, and then a rectangular prism. Now towards the bottom, we're going to be talking a little bit about the difference between the pyramids and the prisms, okay? So we'll take care of pyramids versus prisms, and then cylinders and spheres and cones. We'll talk about the differences there in just a second. But for now, let's make sure you guys got those all matched up. All right, so when given height, our 2D polygons become prisms, okay? So if I take this rectangle and I give it height, now I'm making it a prism, okay? That's what I mean by taking a 2D shape and giving it height. I could take a triangle, and now I'm going to give this thing height, and I've just created a triangular prism, okay? So that's all I mean when I say if you give a 2D polygon a height, it becomes prism. Now, if a circle is given height, it becomes a cylinder. So if I have a circle and I give it height, this shape is called a cylinder. A lot of you might have been tempted to call it a sphere, so we're going to talk about that in a split second, okay? Now down here in the box is where I actually show you guys how to practice drawing some of these shapes. So let's start with a prism, and let's start with the one that you guys are going to be seeing, rectangular prisms. So practice drawing this here with me now. So to draw a rectangular prism, we're just going to draw a rectangle. And whatever rectangle you just drew, you basically want the same one kind of up here, kind of sharing that corner, if you will. Move that down just a little bit. So basically all we've done is drawn a rectangle and then the same rectangle. And then now if you just connect the edges, see how I just sketched the prism? Now to sketch a pyramid, here what we can do, I'm just going to draw a triangle. You guys can see I'm just drawing the triangle. And then above it, I'm just going to extend a line. And then now I'm going to connect here and here. And we just drew a pyramid. Now the difference between the pyramids and the prisms is that the pyramid, it kind of comes up to a point. The prism, it has a rectangular bottom down here, and then it has another one of those. So the prism has a top and a bottom. Well, the pyramid only has a bottom because it comes up to a point, okay? So pyramid has one point. The triangular prisms, or the rectangular prisms, do not come up to a point. A square pyramid is a little tougher to sketch. You almost kind of start here with like a parallelogram or a rhombus, if you will. So it's like a slanted figure. And then basically I just draw a triangle like that and then connect down here and then right here and here. This one's a little tougher, but this one looks a lot like the Great Pyramids that you see in Egypt. But that's what a pyramid is. The pyramid comes up to 1 point. Okay, cool. Now let's explore a little bit cylinders versus spheres versus cones. So a cylinder is when you take a circle and then you give it some height. So basically you want the circle to look like an oval. And when you connect right there, you've just drawn a cylinder. Now a sphere is kind of like a ball. And a lot of times we show that with like a curved line like this. And then another curved line, kind of like this. And that's just a way to kind of show that this circle is actually meant to be a 3D sphere. And then for a cone, it's still a circle on the bottom, but kind of like a pyramid, it comes up to a point. So we've got a prism here and then two pyramids. Here we see a cylinder, a sphere, and a cone, and I'm just kind of practicing drawing these shapes with y'all. You can even see here that my shapes aren't perfect, and they're not meant to be perfect. I'm writing with a computer right here, and you guys don't have rulers, so it's okay if they're not perfect. Another example of a cylinder is you could draw kind of an up-down oval, see like this, and it almost now looks like the cylinder is on its side, but that's how you draw those cylinders, okay? So we basically are going from the 2D stuff to 3D in this unit. All right, now let's flip over. And we're going to just practice taking a look at these different figures using like the different views. So for example, we might have the way it looks from the front, the top, and the side. And we're going to say, all right, based on these views, which one of these figures has to be it? Now you can see what I've done to kind of help get us started is I've just highlighted. So like the front would be the yellow sides. So here's the yellow sides in all of these figures. Now, based on that, I think you guys would all agree that we can see that it's going to be figure 3 right here. Because from the front, we have right here and here. There it is right there and there. Now, the top view, see how I've got 3 of them? So this is the 1, 2, 3, 1, 2, 3 green that I would see from the top. And then from the side, I'm going to let the side be this pink right here. So from the side, there's the 1, 2, and there's the third one you'd see from the side. So this figure right here, figure 3, is the 3-dimensional model if we use these 2-dimensional views. Now, part of what we're going to be looking at in this unit is how to cover up the 3D shape or the actual volume that it takes on the inside. So if I want to know the surface area of this figure, I can see 1, 2, 3, 4, 5 on the front. My yellow, I see 5 on the front. Now for the top, I see 1, 2, 3 faces. And on the side, I have 1, 2, 3 faces. So surface area, we're just looking at all the faces we can see. But just because we can see the front, we have to assume we know that there's also the back. So if there were 5 from the front, I'm going to double that and say there's really 10 if I look at front and back. Same thing for the top, y'all. For the top, there's 1, 2, 3. But what about the bottom here? So I don't care about just the top. I care about the bottom as well. So the 3 on the top and on bottom is now 6. And then here, 1, 2, 3 faces. But what about the 3 on the side that I can't see? So it's not just the 3 from the side I can see. It's actually double that from the side I cannot see. So the surface area, if I just count like all of the faces that I can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then was there 12 of them? 1, 2, 3 greens, 1, 2, 3, and then 1, 2, 3, 4, 5. All right, cool. So that's the 11. And then if we just double it, we're going to get 22. Okay. So the surface area is 22. Or another way to think of it is adding these numbers up. The 10 was the front and the back, the top and bottom, and then the 2 sides, and there's the 22. So we've got 22 for the surface area, and then for the volume, you just want to count how many cubes there are. We've got 1, 2, 3 cubes, and then 4, 5 right on top. So there's 5 cubes total. All right? Cool. Now let's move on to number 2. So it asks, which figure is the front view of the object? So looking at the three-dimensional thing, the front is over here. So for the front, we just have, let me actually pick a smaller marker. Boop. The front is 1, 2, 3, 4, 5. That is what we could see from the front if we were looking only at that thing. So I see 1, 2, 3, and then a 4 and a 5 right there. So right here, figure 4 shows there's the 1, 2, 3, and then the 5 and the 6 right there. Boom, there it is. So figure 4 is the correct answer for this one. Figure 4 shows the front view of this three-dimensional object. Friendly reminder that it is fair game for me to ask for surface area and volume. So for surface area from the front, we can see 1, 2, 3, 4, 5. There's those 5. But what about the back? So we have 10. All right. The right view, we have 1, 2, 3, 4, 5, 6, 7. But then all of those have the other side. So these 7 times 2 is 14. And then the top view would be 1, 2, 3, 4, 5, 6, 7, 8. So we can see 8 from the top, which means there's also 8 on the bottom. So this is my entire surface. I've got the 10 from the front and the back. 14 is my right side, and then the other side I can't see. And then the 16 is the 8 from the top, and then the 8 on the bottom. This right here is 30 plus 10 more. The surface area is 40. We have 40 faces on this object. There's 40 faces. Now for the volume, it's just how many cubes do we see? So I see 1, 2, 3, 4, 5, 6, 7, 8, 9. But we can't forget that these two must be on top of something underneath it. So the ones we can see, again, are 1, 2, 3, 4, 5, 6, 7, 8, 9. But we know there must be a 10th one up underneath it. So there's 10 cubes total in this thingy. So there's a volume of 10 cubes. All right, now for the next one, for number 3, it asks which shows the right view. So from the right-hand side, we would be able to see 1, 2, 3, 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Oh, we can immediately knock this one out now. Now there's 4 more over here. 1, 2, 3, 4. 1, 2, 3, 4. Uh-oh, I don't have them here. So figure 1's out. Figure 3 has them as well. Now right here, we still see another one without one right on top of it, which would be this guy right here in figure 3. See how figure 2 implies that there would be another one on top of it, which we don't have one there, so we're not going to pick figure 2. So figure 3 is the one that matches here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got all the faces right there. Now, just for the sake of time, I'm not going to worry about trying to find surface area and volume for any of the other shapes. So I'm just going to cross those out. I know that wasn't in your notes, but for these first two up here, I kind of just wanted to show you a little bit what we're going to be doing in this unit, which is finding both the number of outside faces for surface area or the number of total cubes that make up the shape for volume. Okay? All right, so we answered number 3. Now we're on number 4. So for number 4, it wants to know which figure matches the views. Now the front, the right, and the top are shown. For the front right here, it's basically going to make kind of like an L shape. So we're going to just basically see 1, 2, 3 from the front, which would be like this 1, 2, 3. So figure 1 is fair game still. Figure 2, I see 1, 2, 3. That's the 1, 2, 3. So those are both fair game. Here I see 1, 2, 3. So on top of itself, this one is 1 on top of here, which is right here, and then next to it. So this is still fair game. But figure 4, we're going to now take out of the running because from that front view, figure 4 would look like this. See how it's 1, 2, and then 3, 4? So 1, 2, 3, 4. That is not the front view that we're looking at, so it's not going to be this figure. Now let's look at the top. From the top, I'm going to count 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. This one's in the running. 1, 2, 3, 4, 5. Oh, we're going to eliminate that one. Now the 1, 2, 3, 4, 5, 6, you'll notice that these need to be making a square. And right here from above, I don't have that. I don't have that, so I'm going to eliminate this one. From above, I could see the 1, 2, 3, 4 that I was just telling you about. That's those 4. And then here's 5 and 6, and there's 5 and 6. So figure 1 is the one that matches. This is the 3D shape using these two-dimensional views. So again, 2D views to find the 3D shape. Now for this one, which net forms a cube, I'm actually going to switch over real quick and let this play. You can see that I have a 3D cube. It has 6 faces. And see how it unfolds? And these are the 6 faces that would have made that net. So when I come back over here, if I want to know which net forms a cube, I need 6 faces. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Whoop, that one's out. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now these figures have 6 faces, but you can see that this is the one right here that folds up to be the cube. So figure 3 is the one that folds up to be a cube. And in case you missed that, I'll just go back real quick here. Watch this cube unfold. Boom, boom, boom. There are the 6 faces that make a cube. Okay? All right, so that concludes this video. What you're going to do next is you're actually going to be watching a video for how to find the surface area of these rectangular prisms, but that's going to be a separate video. So thank you for watching.